I can show you guys a little bit of the skills folder that I have and kind of explain through a little bit of why it works this way. I think at a higher overview, having skills in this folder webbed way is useful to be able to map it for your Claude to kind of notice that it needs to do something at a certain time without overwhelming its context window. And the reason for that is because that's when you start to see that it gets very bloated and confused. So right here, Claude.md is kind of like memory, persistent memory. And so it loads every time and is able to understand the sort of thing that you've been working on, kind of just I don't know, here and there, I guess. And then from there, your skills will be triggered upon certain types of wording within your skills folder. And then within the skills folder, I guess there's this subfolder where you can kind of start to create references. So as you can see right here, here's a certain skill for the web that I've been creating just to do things like web scraping, to be honest, and kind of just going around as a bot and avoiding detection. So I have different references depending on what I need to be able to use. And I think overall, sometimes I've been hearing what is a great starter place. I think this skills creator is the easiest one to start getting started with, because once you're able to give your Claude this URL, and after that you give it this URL, and then it'll kind of start to read all the information, put it in its folders, I guess, at a high level. And then from there, you can start to give it more skills, so then you're able to kind of organize itself with it. And then after that, I started giving it the web thing, so then it can kind of start to fetch all these other things behind walled off pages like LinkedIn. That is a good overview. Yeah, I guess, yeah, that's a good overview for a foundation.
Any questions? How many people have created an OpenClaw so far? How many people want to? No? Not everyone?
Yeah, I guess the good thing about creating your own is that you can kind of tell it's a bit safer, because you can do things locally first before trying to put things on a backend or a Raspberry Pi. I think that's the next step for me, but I think overall, as you were mentioning earlier, this is kind of just a foundation. And then from there, it makes it a bit easier, because a lot of people are more willing than ever to kind of put everything condensed of all the years of knowledge. And I've been finding a lot of different types of skills that I can kind of just get off the internet, feed it, and then with the skill creator, it starts to really kind of just dive into it. So one of them is a search engine optimization skill creator that I found, and it's been helping a lot.
Okay, I'm going to be talking about some AI ad generation I'm doing. So for some context, I'm working with a marketing agency that creates ads for home service businesses. So this is an example of an ad they created. Actually, that's not the example. Let me pull up the example.
Tripping every time you run a few things at once. That's not just annoying. That's your telling you.
Okay, the audio doesn't work through the TV. I'll just play it through my laptop and hope it's loud enough.
If you're a Seattle homeowner and your breakers keep tripping every time you run a few things at once, that's not just annoying. That's your panel telling you it's done. Most Seattle homes were built decades ago. The electrical...
So I think that demonstrates the point. Basically, the value add is they actually record the business owners and the same person that's going to be doing the work at your house in the ad. So it's supposed to build a better level of trust than a static image or a more generic advertisement. The bottleneck they were running into is it's just a lot of work to drive to a client's site, send a videographer, record the ad, and then also they're not actors, they don't know how to speak on camera well, you need a teleprompter. It's a lot of work to actually make these advertisements, even if they're only like a minute long. So my boss, he asked me if it's possible to speed this up using AI, very open-ended question. And so my goal was to essentially create just this first 2-second clip using AI. So I still wanted it to be Eli. Eli's this guy who owns an electric company. In the advertisement, I wanted it to be him talking, but I didn't want to have to send a videographer on site. So this is what I was able to do. So I had heard of an image model called Kling Motion Control, and what it does is it takes the motion from a video and applies it to an image. So what I did was I made our videographer act out the first scene in that video to get the motion. So let me just play this audio.
If you're a Seattle homeowner and your breakers keep tripping every time you run a few more things at once, that's not just annoying, it's your home trying to tell you.
So that was us acting out just this first
If you're
clip.
a Seattle homeowner and your breakers keep tripping every time you run a few things at once,
So then I took that video and I gave it to Kling Motion Control. So
if you're a Seattle homeowner and your breakers keep tripping every time you run a few more things out,
okay, so the input was the video I recorded of Richard, our videographer, so we didn't go on the client site, and an input image of the person we're trying to make acting in this video. And this is the output that it gave us.
if you're a Seattle homeowner and your breakers keep tripping every time you run a few more things at once, that's not just annoying, it's your home trying to tell you something.
So I think that's like 80% the way there. Obviously, that's just the first scene in the ad. You need to do it like 8 times. But the value add is we can record the video in our office, not have to send out a videographer driving to, I don't know, like Tacoma or Mount Vernon or wherever the client is. Our videographer, he knows how to act. We don't know how to coach him how to speak on camera, and we already have like all our gear set up on site. But just to go back to the video that was created by Kling Motion, it's not perfect when you look at it. If you look at the lips closely, it's not dubbed to what he's saying. I think it'll be more clear when I play it.
Homeowner and your breakers keep tripping every time you run a few more things at once, that's not just annoying, it's your home trying to tell you something.
So, it's not dubbed to his lips correctly, and additionally, it's not even him talking, it's Richard's voice. So I needed to do the last gap, which was adding Eli's voice in and dubbing the mouth correctly. So the way I did that was I used 11 Labs to voice clone Eli using the audio we had in the video. And then I used a lip syncing model to sync the video, specifically the lip movements and facial movements, to the audio. And so this is the output of that.
if you're a Seattle homeowner and your breakers keep tripping every time you run a few more things at once, that's not just annoying, it's your home trying to...
So that's Eli acting, Eli's voice, same background. Eli's mouth, kind of, probably. Well,
motion.
Eli's motion, yes. And just for reference, this was the original clip.
If you're a Seattle homeowner and your breakers keep tripping every time you run a few things at once, that's not...
So, this is something we're now implementing for ad creatives with the consent of the business owner. So obviously they need a consent to their likeness being used to create an AI video of them. They need a consent for their voice being cloned. But what that means is we can do it for a cheaper price because we don't need to send a videographer, which costs hundreds of dollars and a lot of time and gas and everything. And we can create creatives a lot more quickly. Like we previously created like about 10 a month. Now we can do that in a week. So, and with the same amount of employees. So productivity is essentially 4x in our like editing and videography department, which is amazing for our business. And then the last thing I wanted to say is I think this is an interesting use case where using AI might actually reduce CO2 emissions, because I know a lot of people are concerned about AI using a lot of water and CO2, but previously we drive like 2 or 3 hours to a client's site, and from a CO2 perspective, if you zoom in on this application, it actually saves a lot of emissions, which is pretty interesting. I've never heard AI doing something like that. And it's also probably one of the more useful applications of Kling motion control. I think a very infamous use case of it is like the Palantir CEO who did like an interview, and someone used Kling motion control to make him do a handstand, and people thought it was real. It looked really believable. So someone they must have done a handstand and then used that video on him and made him look like he did a handstand in the interview. And the reason why I'm mentioning this is that's, in my opinion, a really dumb use of AI. And now we can use it for things that are a little bit more productive. So yeah, I guess that's the conclusion of my talk. Yeah?
Can you go through that process or step one more time of how you were moving past Kling motion control to work on that fine details of the mouse?
Yeah, absolutely. So the end-to-end is you need a picture of the client or whoever you're trying to make in the video. You use someone acting out what you want to occur in the video. You use Kling motion control to make the rough video that doesn't have the lips being synced. Then you go to 11 Labs or any voice cloning tool, and you provide a sample of them talking, and you would clone their voice, and then you would use a voice changing tool to put in the original audio and make it so that they're speaking using the cloned voice. And then you would get a lip sync model, which I think is what answers your question. So I'm using Sync Lip Sync 2 Pro to make their mouth the correct movements. And then lastly, you could use an upscaler model if you want it to be more high definition. It costs roughly like 30 cents to produce what I just showed you for reference. Yeah?
Would it work if your videographer wasn't white?
Actually, that's a very good question, and the answer is no, because I tried doing it using me, and it did not work at all. But if the client was brown, it could work on me. So I guess yeah, I'll finish that thought there. Yeah. Yeah. So any home service business is a prospective client for us, and we run ads for them. So we work with like plumbers, roofers, electrical companies. The value add in their minds is that since they're the one on camera, it builds a stronger level of trust than like a static image or a generic ad. And from like a conversion perspective, that shows. So that's kind of the prospective clients.
So the problem that this is solving is that the electrician need to kind of market their skill set through the video, and then the video that AI generated build more trust with the homeowners.
No, the problem it's solving is that we have to send a videographer on site, like physically on site. So you maybe have to drive an hour or 2 hours wherever they are, or if they're in a different state, you need to either have a videographer there or contract one. And then also they're not an actor. They might be awkward on camera, and we have employees who, they're not actors, but they can act in ad capacity.
Do you also help to target the audience? This is for social media, I'm assuming.
Yeah, I zoomed in on like the AI application, but like we do everything marketing for our businesses. So we run their ad campaigns, we run their social media, we run their website, we run their SEO. Absolutely everything. So actually, if you know a home service business, they should definitely go here, fill out this form.
How do you charge per lead or what?
Oh, we charge in like month intervals. So like the first 3 months, I don't want to say how much, but we charge a set amount for the first 3 months. You'll get 5 creatives, which this is like an example of one of the creatives. You'll get all 5. We'll run the ad campaign. We'll build your social media.
Why not per lead?
Why not per lead? It's a good question. We at the current moment we've only been around for like 6 months, so we do kind of need cash flow upfront to fund payroll. But we could move to per lead. I think honestly it'd probably be more profitable per lead, but I think it just made the most sense given like where we were at. Yeah.
It's a wonderful presentation. You mentioned 11 labs and promotion in your stack. I guess 11 labs and contested is where you go for employees. But for promotion, are there other tools that you'd be looking at, and what are the trade-offs there?
Yeah, so we already had an 11 Labs subscription for text-to-speech in videos, and then 11 Labs just happened to service models that I wanted, like Kling 3.0 motion control, but yeah, 11 Labs doesn't make these models, they just serve them, so any provider of these would be great. 11 Labs also doesn't have an API for their image and video, so the product I'm building to make this work end-to-end without having to drag and drop doesn't use 11 Labs, it actually just calls directly to the Kling API. Does that answer your question?
Let's ask more specifically replacements for Kling. Why Kling? Are there other models? Is there a specific use case for using Kling versus, in another situation you use something else? I think
Kling is just the best model I've used for that application. They also went really hard on like advertising, so maybe like they converted me and it worked. But I could definitely try other motion control models, but it just like fits all the boxes. It's affordable, it's fast, it does a pretty good job in my opinion. So I don't really see a reason to shop around, but that's a good question.
Have you seen the South Park episode on the Handyman?
I have not.
Has anyone? It's like AI, takes over the world, and so like Randy tells AI to go fix the refrigerator. He's like, sure, and it doesn't do anything, and so the handymen become the billionaires because they're the only things that can do stuff that AI doesn't. So you guys should go watch that.
Yeah. I think it's also important to know there's still someone acting out. This is not like a fully like prompt-driven.
No, or your customer base.
Yeah.
It's a good customer base to target.
Do you think it matters whether this is the owner of the business or just some dude that looks approachable?
It matters a lot that the same person who's going to be servicing you is in the video, because the idea is you built a certain level of trust or authenticity, or you kind of associate, like if you see Eli 5 times on social media talking about fixing your like electrical panels, you kind of mentally associate him with like, oh, he's the guy I turn to for electrical work.
He's not the one coming to fix it.
He is the one coming to fix it.
Oh, he's like the sole proprietor, and then also.
Yeah, I mean, most of these home service businesses are like 4 employees. They're just like, plumbing businesses can be 2 employees. Like, I don't know how big Eli's is in particular, but.
Do you call Eli and then the familiar voice picks up?
Well, we have a call center, so actually, a call center agent would pick it up, but yeah, I don't know why I mentioned that. Yeah, you're right.
You probably could have done it without.
Clone his voice and put it on the call.
No, but like even if there was the lip thing would not be. I mean, I wonder if the conversion would be a lot worse. Probably not that much.
Wait, one more time?
If the phone screen is so little, not a lot of people will even notice that there's a discrepancy of what he's saying because it's so and his voice, who cares? It looks true, so it doesn't matter.
Yeah, I mean that's true, but it's like 6 cents to have like an API call to fix it, and it adds something, maybe not a lot, and it takes like 20 seconds or so. So yeah.
What's the name of the company?
It's called Akula. So you can go to akula.com. You can fill out the form if you're a home service business, and you get a lot of leads. And we wouldn't charge you a commission per lead.
Cool. Thanks.
Hey folks, so we are the team Bracket, and all of us are, I think, nowadays vibe coding. And what a gap we discovered was that when your projects get a little bigger, you actually don't know what's happening. Earlier we used to use Postman and a bunch of other tools to understand what our APIs are doing, what is actually happening. Like everyone used to have a mind map of what is going on with our projects. But now, as our projects grew, we found the need that yes, we are not able to have a mind map of what all is happening. So for that, we built Bracket. What it does is it basically gives you an idea of your entire system. It gives you a mind map. It gives you a very visual way to understand what your APIs are doing.
Hi everyone. So think about like the previous way of writing APIs. If you click some action on a website, you go to developer tools and you just see like 200 when it's successful, or maybe 400 when it is unsuccessful. But with Bracket, we are changing that scenario. So it's been a month. We started with like because we were building, of course, AI tools like AI websites and everything. And the problem that we faced was essentially how it started was, I can go back and just talk about like how we started this project was doing all the vibe coding, and then one of my project, which was also the AI video generation, was leaking like the whole schema, and I've not known about it. So the whole idea was like, if it is happening to me, it could happen to everyone else. So we started doing what can we do. There are many tools that does this, like PostHog, DataHog, but these are all cloud side. So we thought like how we can help developers who are like vibe coding. So this was the idea. How we started with the tech stack. Actually, if you see this is an open source project. It's all TypeScript, and we just wanted to do something which sits between your app and the network. So AI is taking over all the front end stuff. So I thought the network layer is still very unexplored. So that's what we did. Like we just went there and started coding and learning about like what's reverse proxy, how we can code something cool so that these errors that happen to me can be caught before it goes to production. So I guess from today, in next 1 or 2 years, this kind of issue will be more amplified, because let's be honest, live coding is hard because it flows out of your hand very quickly. So that was the idea behind Bracket. Yeah.
And how many people have had like these kind of issues that this would solve?
I mean, yeah.
I'm curious. Right?
Sometimes you
either it's like known or unknown. I guess.
The idea is actually it's more like we don't understand after a while, because initially you said we used to use Postman, like before we even create our software we used to do an APIs, but now we just like go to Cloud and just say, hey, this is my requirement, do it. So we are getting more unknown about like that area. So it's more like it's kind of our question. Yeah.
So for our development team, we use Claude Code's hooks to do a lot of this. We have a lot of hard-coded security agents that are specified to run at particular lifecycle moments while Claude Code is in development. I'm curious how long you think this type of a solution would stand as these coding agents are providing more and more flexibility for us to add hooks and custom sub-agents to be run at specific lifecycle points that I can tailor to our specific security tooling within our enterprise.
Yeah. So the whole idea for this was to be local first, and I know like a lot of agents are local first as well now. I know the window is getting shorter day by day, so I have no idea for like how long it would stand, but still we thought the network layer is pretty wide open, and like agents are good at like writing your code, but the APIs that you're writing, or maybe the AI is writing, is still like pretty messy and wide open. So that was our thing. Like, let's do it before, or Claude will do it first. Like Anthropic is after it, because they just release security, like Claude for security. But it's all still production. It's not the local first thing. So that's what we're trying to go after.
Yeah, I think it would be super interesting to kind of just, it doesn't have to be now, but we need to really talk about like how you guys encountered this problem, how people should be thinking about it, because I think a lot of people probably aren't, right? Like, I mean, it sounds like you weren't necessarily thinking about it until you saw it creating an error, and then you're like, oh, I'm going to dig into this and stuff like that.
Yeah.
So, yeah, that's interesting. It's like a lot of people probably don't know that this is an issue, maybe, and we've seen that with a lot of, you know, like non-professional vibe-coded apps.
It's not only the security part, it's also like we thought like, hey, the more we move forward, the performance shrinks. Sometimes some other API regress because of some other code. That is also like a very wide open area. But because the tool that we created it does not see just a particular section of the API, but it sees the whole user journey of like the whole application together. So we were able to map this, like the journey of your API throughout your like local use of your app itself. So maybe like yesterday it was fine, but after like 5 more iterations of your like coding session, it might have deteriorated. So that's what we want to do. Like anything that just gets out of your security and perf realm, it should be catched before it goes to production. So that's the whole intention of this. Maybe agents would be there for sure, but I think it's about speed now.
I would argue, well, earlier when you asked if there was anybody that wasn't a fan of the vibe coding term, I raised my hand. I'm a really big fan of what's coming to be known as specification-driven development. It's really the antithesis of vibe coding, where usually the abstract idea of what you want to build exists in the mind of the engineer, and the code is the artifact that comes from it. But specification-driven development kind of turns that around, where the spec file itself becomes the artifact. This is really all the engineers work with and start from. And then the code can just be generated every single time over and over from the spec sheet. And I would argue that from a lens of specification-driven development, where you clearly define what the endpoint is supposed to be, what the data contracts are, what input and output formats should look like, what verification and validation look like for a successful build, then when you have another whiteboarding session and the API changes, you change your specification sheet and you don't have any problems anymore. It's always updated from the spec sheet.
Right. But then, like, think about a founder who's just like starting solo and just want to get his MVP out, and then maybe he gets some traction and then he moves forward. Yeah, I don't want to make a spec sheet. So the initial, I mean, of course, I agree with your point, but this is more like, what if like there's just 2 people teamwork just like building very fast? So it's just like a layer that helps you like not like leave any traces in the production. So
yeah, I just you don't want to build a spec sheet, but you might end up spending more time fixing all the bugs that you could prevent in the first place by doing a little homework and actually a problem clearly stated as a problem half solved, which is what the spec sheet design is intended to do.
To Adam's point, a lot of us really don't know what issues to anticipate. I mean, when I'm coding, one of the few things I check for is if I'm calling external models, what is the cost versus length versus quality. And that's the only thing I'm tracking using APIs. But outside of that, I'm like, I don't know what could go wrong. I know we didn't really look at a product demo, but if you have some thoughts on these are things you have to look for.
yeah, so there was this very interesting LinkedIn post went very viral about. Actually, that was also one of my idea. Like, hey, this could happen. So what happened was there was a registration page that was posted for like hey, early signups, and the sign up page was sending all the users email just to show the count. Someone went to the network layer and then just saw like, hey, I can see all the emails here. So these small little things, of course, it like at that point it was like, hey, it's working. I'm seeing the numbers. It was right for it for sure. And then, but what it did was it was doing the select star from user table and then making a count out of it later. So sometimes it does look fine to us, but what happens in the API level, what the responses coming back in in terms of some PII data, maybe like email plus maybe some SSN number. You might not know, or maybe you might not have understood it well. I'm not saying it's happened, it's not regular, but it could. So that was the idea. So it's like just maybe sometimes the error console.
I'm definitely sold on the problem.
Yeah.
But what I'm trying to understand is what types of problems can I anticipate? You gave me one example, but if you're
It's like bracket to help you identify those problems.
On the website there is a list of multiple rules we have.
Yeah. So we have these rules that we actually. So sometimes the secrets are exposed, or maybe just the tokens in the URL. The best thing that I got to know from my own mistake was the stack trace leak. So I did like error.console and just left it there because I was debugging. Somehow it was there in production. It was showing me like when the error happened, boom, all like full DB schema was there. So yeah, look for these. This sounds like the error info leak. Stack trace and error info are like pretty easy to just.
Yeah, I mean, I would say if you like, I mean, it depends who your target market is, right? Like if it's like professional developers that are using Quad Code,
yeah,
like maybe that's going to be solved soon. If it's people that aren't professional developers that are using other tools that don't actually know what to look for, like
yeah,
that could be helpful. I mean, again, like apps know that security is important and their platforms are adding to it. But I don't know how good each one of them is.
yeah. I mean, I agree. You had a question.
I was just thinking, sometimes a new model gets released and I haven't, reviewed the code and then it's like, oh, I found this bug, and I'm like, oh, nice. Clearly this model is smarter. Do you think the models will get smart enough where they won't make these mistakes?
Yes and no. I'll be very honest about this. What I do is, like my workflow was for this. I would do some white coding. I would just go into the new window and I would say, hey, this is my state changes. Just go and review it. And I had like a prompt that I would just give it, like go for the reliability, performance, and if there's code smells, if there's a design system issue, just flag it and let's make a plan out of it. It does perfectly, and it just gives me a whole plan. There are a bunch of issues that I fix. Then I do the same thing again with the fix that it has done. The second prompt, the same prompt I give, it finds more issues. So it's you feel good like, hey, it found something, but then there's something else that it might have made, or maybe it might have missed. So I think not every, like one solution is not always a perfect one. So maybe one agent might not be able to solve every issue that might be in the code base. So I really feel good when it solves the issue, but then the second time I run it again, it finds something new. So
is it similar to, I don't fully get it, but is it similar to when that vault book came out and then everyone's secrets got exposed? That is similar to what I'm talking about?
So no. So security is just like a tiny bit part of this project. So security is a part, because the whole idea was like, if you can see the whole API locally first, what else you can do from it? So maybe you can create a graph out of it. You white code the whole app, but then as I'm 100% sure, everyone over here might have gone through this cycle of like, I don't understand what this code does after a certain point of time. Until you are reviewing it, everything it does, but the amount of code that it generates, it's very hard for you to keep understanding. And you see the output, you feel fine, and then you're like, I'll come back to it later and then understand it, but then the train is gone. So the more we write code, the less we understand, and this is gonna amplify for sure. So the idea was, the way it started was like, we will help you understand the network layer first. But then what we also thought that while you're understanding this, you can also fix these things, because you can clearly do, because you have all the APIs, you have all the endpoints for database, you have everything. So what else you can do? So that's how it progressed. So security is a very small part of it. Then you have performance, and then you have graph that as you are using your whole app, it maps up the whole graph for you. So we use like S3G for that. So that was the idea. Thanks, everyone.
I'm affiliate faculty at FSU, and this is some of the research that I've been working on. I think it's really important because you think about the future of AI agents. Vibe coding is the now, but what's the tomorrow? So how many of you have built an AI agent before? And when you build your agent, you ask it to do tasks for you, and you want it to accomplish things, but its agency comes from the tools and the skills that we endow them with. And quite regularly, you ask it to do a thing, and it can't complete the task because it has a skill gap, right? It's like, oh, and so now you have to go create a new tool, you need to spin up some new MCP server, or go find an existing MCP server to integrate it to solve that. So why I think this matters here, and we build with AI, is that the need for that will start to disappear when our agents can discover other agents dynamically and recruit them to solve more complex tasks. So how does this work, right? That's what basically what I'm going to skim through here to kind of give you a big picture. So this is just an article from some research notes from my website. I don't really have anything other than some visuals and stuff to share to communicate it, but I think more people thinking about this problem is going to be good for us. So basically the three pillars of a dynamic agent network, you need the first thing, which is identity. How can you discover a thing that isn't well defined, right? So every agent needs to define itself, what it is, and it needs to be somehow exposed in a discoverable way. And then you need discovery. So great, you have an entire internet with a bunch of endpoints that describe what agents are, but you can't go crawl the entire internet to see what agents are available and what they can do. And then you have coordination. So let's assume you solve the first two, where you define every agent, and every agent is somehow discoverable, which is a pretty significant task. Why on earth would some agent running on someone else's compute with other tasks cooperate? Like, where's the economic incentive for this agent to give you its capabilities? And so that's the agent economy. And I think it's interesting to people like us because in the future you're just going to be able to build an agent, deploy it somewhere, and it can just start earning money for you on the side because it's going to be solving tasks, and if you can design it well enough and get it access to sophisticated data and capabilities that other people need, then their agents will recruit it and it'll negotiate some contract dynamically using an agent exchange type framework. And all of the interactions will be logged on blockchain for credibility and auditability, and then some sort of cryptocurrency or something like that will be exchanged at task completion. So to just kind of go through the main layers here, an agent card. How many of you are familiar with agent cards? So that's kind of the underlying premise of the A to A protocol that Google put forth a little while ago. There are many competing standards that are emerging, but like I said earlier on, an agent needs to be able to define itself and it needs to be discoverable. And what does that mean? So just as an example, this is the kind of information you might see in an agent card defined by the A to A standard. It has a name, description, version, etc. Importantly, the capabilities list, right? Here's where it defines what it can offer, right? So yeah, say you have an agent endpoint, you can go look at that agent, but how do you know that that agent's skills are what you actually need to solve the task your agent's trying to solve? So that's where that capability is advertised. And then the skills define very precisely how you would actually call what those capabilities are if you wanted to make a specific request. So here's just a specific example. I'm from health insurance, as I shared. So we're trying to create multi-agents that are able to cooperate with payers, providers, and adjudicate claims or prior auth requests really quickly, so you can just show up at the doctor and not need to deal with your health insurance anymore, because I'm sure all of you hate that just as much as I do. But what I wanted to show you, what I think is important, at least for the first step, is discovery. So assuming agents are defined, that's not a really hard task. That's going to be solved pretty soon. It's just all we need to do is just agree upon the standard, and I think agent cards are kind of emerging for now with the A to A protocol. But now you've got an entire internet with a bunch of well-known endpoints, which is where currently is the common standard to put them. For example, if you want to go find something, you went to Google and you typed something in. How did Google find what you wanted, right? This is basically that problem, but now for agents. So you need an agent, and it wants an agent to solve the problem. Well, there's going to be millions, billions of agents all over the internet, and of all of them, which ones is it going to find, and why, and how is it going to find them? So the first is a centralized index, right? So this is one thing my friends and I are currently doing. We've got a bunch of robots crawling the internet right now, looking at well-known endpoints and trying to aggregate as many agent cards as there are. Most of them are ephemeral and disappear because everyone's just tinkering. But in the future, this database of all these agents is going to be a really valuable place for us to try and surface information to other agents. And so a centralized index where you can actually just find them all and index them and expose them to people will provide us, some leverage to maybe do some sort of a cool startup or something in the future. But another thing that I like a lot is what's called gossip-based discovery. And this is the decentralized propagation of agent discovery. This is really cool. So the analogy here is really great. So imagine arriving at an academic conference and you don't know anybody. You introduce yourself to one person. This is the registry lookup, right? This is the one person, you now have them. And then you say, they say to you, oh, you work in causal inference. You should go talk to Dr. Patel over there, and she'll probably introduce you to the group at table 9 who's working on treatment effects. That's gossip propagation. So your known agent graph of the agents you can query from went from that one person that you got from the agent registry lookup to potentially dozens. And so what happens is agents that have skill sets have their own internal registry of agents that are related or similar for solving tasks. And every time you make an A-to-A connection, you do a little gossip and you share with one another the agents you discover, dynamically growing your own agent internal registries in a decentralized way. And then there's broadcast discovery, but this graph kind of shares what these things look like. So you have the centralized registry, and agents might just look up and query what they want. And then these dotted lines demonstrate gossip-based exchange discoveries, where maybe you agent A queried and then got agent Delta here, but while communicating with agent Delta, it learned about agent Gamma via gossip, and so now that's accessible to it to solve other tasks. And then agent Epsilon over here is broadcast radius. This is type of edge computing, where you have different devices or agents that might want to communicate with each other in a well-defined network. So these are kind of the three main paradigms for agent discovery. And then the main thing here that I wanted to kind of get across that I think is really important is that the main life cycle for these, they're called coalitions, when these agents dynamically discover one another and try and solve tasks, is that you give your task or your request to your agent, and then the first thing it does is decomposes your request into a set of tasks that it needs to execute. You've probably heard of like directed acyclic graphs. It has like a task graph of what needs to be done and in what order. And then it goes ahead and says, okay, well, what tools or skills or agents do I have available to solve this? And then when it finds that one of the tasks it defined, it doesn't have a capability, so that we don't have to go define it, it goes ahead and does this discovery, this recruitment step. And that recruitment step right there is the big one. That's where all the work is at. Like, what is it doing? What central agency, central registry is it querying? How is it discovering new agents? But once it does, it negotiates the protocol, it then executes. But the problem is oftentimes during execution, you realize you have yet another capability gap. And so that's where the loop has to come, and that's the dynamic nature of the coalition formation and dissolution is. And then finally, once the task is complete, the central orchestrating agent dissolves the coalition, logs results in some central registry somewhere, and then it can be used for future lookup with regard to reputation and performance, etc. So there's a lot of really interesting challenges that come along with it, like trust without central authority. So in this talk, I went through the kind of emerging frameworks around decentralized identification. Like how do you prove that you are who you say you are? You don't just want to start communicating with a random agent somewhere. Maybe it's just going to pull information from you and then not help you solve your task at all. So there's risks there. And then the economic incentives and free riding. Yeah, please.
I'm sorry to interrupt you.
I'm just rambling now, man.
It's kind of the existential chicken or the egg situation, I feel like, and to your point earlier about how Google originally found any sites or references, etc. Is that, in your opinion, is that going to be a legislation thing? Is that going to be governed by countries or international coalitions so that secure AI to A is secure for the long term?
From the pattern that I'm seeing, I don't think so, at least not anytime soon. I think progress and innovation is dramatically outpacing legislation and governance. And so I think what will probably happen is, if I'm lucky, people like me working on this might come up with a cool registry or search algorithm that's really valuable to people. People just start using it organically, and then by virtue of just being there first and getting a large registry, I'll get more and more data, market share, more and more information, and then random people will start shaping it.
So Google's not doing that with their their current A cards?
No, so the semantic capability matching is really this. Let me just zoom in onto a figure to show you kind of the complexities of. Let me show you right here. The algorithm for it looks like this. So this was a paper published in 2025, and here's roughly the idea. So you have a query that comes in, and then you have to do all kinds of things, like constraint filtering. Like maybe your query says that whatever agent you communicate with has to be HIPAA compliant. It has certain protocols. Maybe it has to use A2A or MCP. A lot of just basic constraint filtering. Then you have to do some sort of embedding retrieval. So let's start with, you have 10,000 agents based on constraint filtering. Now there's only 800 candidates. Of these 800, you now search through those capabilities that we talked about, look at skills that might actually be relevant, and then you filter that down to the top 20 candidates. And then based on those top 20 candidates, you now do some sort of like an ontology re-ranking, because what if I say, I need an agent that can do some genomic sequencing? How do you define that in a unique way that doesn't conflict with other expressions, that doesn't use any of the exact words in that sentence, right? So ontology re-ranking allows you to do like subsumption, where like maybe this one task can't solve that problem, but these 3 tasks together can solve that problem. So you realize that agents that might not have a single task can actually still solve tasks. Finally, you do some sort of scoring, re-ranking, and fusion, and then you have an LLM as a judge is what they're recommending to shortlist that down. So I showed you this to answer your question now, which is Google doing exactly this? No. As far as I'm aware, no companies or platforms are doing this. What is happening though is like Microsoft has their agent exchange, where you can go ahead and put it up and other people can use it. But that's in a very centralized, they have their own way. Their agents have to conform with a lot of constraints. What I'm hoping will happen is a bit more of a decentralized type approach. That'll be, I think, probably better for the world. But
can I ask one more follow-up there?
Whatever you need, man.
I think it's a brilliant idea. I totally see the need for it, but just as a poking a hole, to help in general, or maybe even to understand it better. What's to stop a single agent from, Opus 5.5, for example, which is widely used by the military, but not by us. It might be able to do gene sequencing right now, because. So I guess my point is, what's to stop a singular agent from being able to do everything that somebody is looking for?
Well, the way that I currently understand it, at least, is context window, context rot, specialization is just things that you can always make one agent fine-tuned on embeddings, that's been instruction fine-tuned on this specific task, that's been fine-tuned on these particular API calls in this subdomain, that will almost always be able to outperform a generalist agent. So I don't think anyone is going to stop a large generalist agent from being able to solve multiple tasks, but I think there will always exist specialized sub-agents that will outperform them and economically drive incentive to use them.
That's fair, yeah.
Yeah, that's my hunch, but others might disagree. Yeah.
So I'm wondering, like in this paradigm, what do you think makes agents autonomous? Like what prevents different people that or different groups who have agents? Like what prevents the agents from just being broken down strict, down to models, or as like the atomic structure or something else? How do you see this agent ecosystem working rather than just like a computation, rather than a compute-based ecosystem.
Can you do me a favor and rephrase that in a different way? I'm not sure I completely understand the question.
Sure. So, basically, like all of this is based on there being an ecosystem where an agent is the atomic thing that is being that are interacting.
Yeah, like a website or something. It's a thing. Yeah.
Yeah.
Okay.
Right. Yeah, like a website with if it were a search engine. So, why is it that an agent why is there an equilibrium, an agent-wise equilibrium, like if that makes sense? Why wouldn't, like if you're faced with a specific problem or complex task, you go and look at, well, what models would be useful for this? And then the intermediate steps are, fine-tuning, then putting, additional prompts, rather than saying, okay, let's go look at these agents that are already created and see how we can.
Yeah. So, if I understand your question, the answer to that is honestly the same thing that drives every one of our answers, whether we want to admit it or not, and that's money. And to create the new tool you need, fine-tune the model to make it more performant, add some new MCP server in front of some legacy data or something, oftentimes that will end up being more expensive in this future that I'm imagining than just recruiting some agent and shaving off a small bit of the total profit you got from computing that task and giving it to that agent for having contributed to its successful conclusion. So, and if that's not the case, then you're right. This agent economy won't emerge. But the way that I'm currently seeing it, and from some of my experiments and people I'm talking to, it seems like this will come. Some form of this will come to be. Yeah. Please.
This is extremely fascinating. I have a lot of questions, but I'm gonna limit myself to 3 questions. First is kind of related to what everyone here has been asking about why would I not go ahead and spawn my own sub-agents. And I guess this is something I've been thinking about at work. So we have like a pretty good task list for founders to go do something, and we have a bunch of agents that we build, but we're like, some of this is so dynamic that we can't really pre-build an agent, and can it at that point spawn its own. And your framework right now is like an agent can identify who it is and what it can do. It can, when it's discovering somebody else, it has to effectively know what is the kind of knowledge. Like if I'm hiring something, I need domain knowledge if I'm hiring somebody, right? So whereas you may think discover, well, it has the capability to understand what domain knowledge and other skills are required.
Absolutely.
At which point, cost apart, what technically stops me from like spotting my own sub-agent?
So basically, you discover it, you look at its spec sheet, you get the description of all of its skills and capabilities, and you're like, great, now I'm just going to go have another agent dynamically create this agent for me to solve this task for me. Well, because the same thing that is the moat for almost any one of our companies now, and that's data. So oftentimes, I think the agents that I'm seeing that are, or at least the services, which might eventually be abstracted via an agent layer, are built around data moats and access to resources. So your agent, say you work at a really big company, that company has a lot of data, a lot of internal services or endpoints or capabilities that, yeah, you could rebuild it eventually, but how much data are you going to need to do that? How much are you going to need to fine-tune your model to get there, et cetera? I think you'll get a blueprint for an agent, but it's like I can give you a blueprint on how to build a nuclear reactor, but good luck doing it without going and getting uranium and all that kind of stuff. That's the analogy that I'm thinking of with regard to that question.
Yeah.
I'll move our second and third question together. I love where this is going. It's very much in need. So if we were to envision this becoming a practical possibility, how would you see this come out as a first stage? For me, when you're talking about it, I could imagine 2 different. One is the Google type search that you talk about. It's like you go out there, see what is out there, and I'm like, A, that sounds complex to me, and B, I could also see how it's kind of political if somebody doesn't really want to.
Absolutely.
Your agents. Another is a more composite serving model with more open source. Right now, if I want to hire a bunch of tools, I just think of it as composite. And you have a platform where people can actually enlist their agents, and you just hire from there. But these are just 2 variations in my head. Where would you see this going?
Yeah, this is an excellent question. I think about this quite often. So, firstly, Google, it works. It has its crawlers. You reach the robot.txt files on your websites and uses PageRank, and it only came to fruition because when you type something in and hit enter, the information that it gave you was valuable enough that you wanted to go back to Google again. Like, it somehow found things relevant enough that it was useful. So how do I see it coming to fruition? Well, one approach is what we're currently doing, which is we're trying to build a large enough repository of agents in our database such that once we just make an endpoint to people who say, oh, let me give it a shot, and you just let your agent write a natural language query and say, give me 3 agents that might help me solve this task. And as long as those 3 agents that are returned, however we do it, and by however we do it, I'm kind of giving you the secret sauce here, if that's useful, then people will keep using it. However, it centralizes that into one algorithm that's abstracted away, and one person, one entity, one corporation, one board of directors is going to be in charge of that. So I have also been exploring coordination without a central coordinator. So this is basically decentralized emergent order where everybody can just kind of put your own agents there and self-discover one another to solve tasks without having a central orchestrator that needs a central registry lookup. And I have mixed feelings about that just because I think I'm a good person and I would like to do it in a way that I think is good for the world, right? But that often ends up not going so well. So I think it's really important that we all consider these alternatives as well. So this would be kind of a whole talk in itself, but there are other ways to do this that kind of go along with spontaneous emergence, like voids, flocks of birds. Like, how do they create structure out of a lack of central orchestration? And so it's complexity theory. There's a lot of really exciting research in this space that's trying to give structure to what such a world could look like. But then now there's new risks, like emergent risks. Like, what if you have a bunch of dynamic agents that start creating some super intelligence in a way that's difficult to control or oversee, right? And these are a bit more existential, but also real. So.
Last question is real quick.
Sure.
Is how far away are we from having such structures emerge?
That's a good question. Well, 6 months. Yeah, I mean they're happening already. So so there's one form of decentralization, which is basically the scratchpad, where you have lots of agents that all write to a central shared memory, and they can all read and share thoughts with one another. And capability, so if you have 4 agents that are specialized in these 4 tasks, and they're all reading and writing from the same scratchpad, oftentimes collectively they can solve tasks beyond what any one of them, the sum of the parts is greater, or the sum of the parts is greater than the something of the whole. That expression is taking place with just small controlled experiments. So it's definitely possible, but before we can see it in a way that I think is concerning, we would need some sort of agentic web existing where there's effective, structured, quick communication with A-to-A discovery, and I think that'll take a little bit longer. 6 months might be a little soon to at least see it in any sort of a serious way where it's in the news and suddenly some weird random emergent AI phenomenon is, I don't know, taking down some energy grid or something. That'll be probably a good couple more years. But please.
Yeah. I really like this idea. The way I feel like why I would need to discover agents is because my agents are not smart enough. So that would mean the other agents that I'm discovering, they are trained on proprietary data or something that's not generally available. With that regard, how do you solve the problem of authentication? Because right now we know there's a particular agent, we need to authenticate with it to use its capabilities. If we just discover it, the authentication part, I'm not very clear.
Yeah. So here's the emerging tech stack for that. So at the first level is decentralized identifiers, DIDs. This came to be the Internet Something Exchange Task Force codified this in 2025. This is a new decentralized identification framework. Then verifiable credentials is what goes on top of that. First, the DID is how you prove you are who you say you are. Like if you have a passport, it's basically like a passport for an agent. There's some cryptographic techniques that can use to prove that you are who you say you are. First is, are you who you say you are? But then there's, can you actually do what you say you can do, right? So yeah, I might apply for a job and I can show them my passport and I am who I say I am, but I'm a great, coder, hire me. Well, how do you prove that, right? So verifiable credentials is the next step, so that you know who you're recruiting, they can actually do what they say they can do. Unfortunately, there's a lot of problems about exchanging information, especially with like PPI, PHI, and privacy. So then there's a layer of zero-knowledge proofs, which is a pretty exciting area of research about how can I convince you that something is true without showing you any information. Like, what's the minimum amount of information necessary for me to convince you in like an absolute sense that something's true without sharing it with you? I don't want to give you my HIPAA credentials. I don't want to tell you which company I come from. I don't want that. I want to give you some cryptographic proof that I am who I say I am and that I can do what I say I can do. So that's zero knowledge proofs. And then at the very top is the reputation and history that comes from all transactions being logged in some sort of a blockchain that's verifiable, auditable. So you can see that some agent has been acting nefariously. And so when you go to recruit through the registry, you're like, yeah, but this one agent bailed on 6 tasks and didn't complete any of them and took the data and the information. So we're going to blacklist this agent and not recruit them in any future tasks. So this is the stack that I'm seeing emerge around that. Probably running out of time.
Yeah, so leave a few minutes so I can like wrap
thanks.
it up, but definitely can stay a little after to answer questions.
Thank you all for your attention and the opportunity.